Alright, you guys, we are back with Unit 2D review. We're going to do pages 2 and 3, evens here. So we're still graphing systems. I'm going to graph the first one in black and then maybe the second one in that purple color. Remember, when we are trying to graph, you always want to solve for y equals mx plus b. So the first thing I'm going to do here is subtract the x from both sides. So I have negative 2y less than or equal to negative x minus 4. Man, I knew that pen was going out and I didn't do anything about it. Negative 2y less than or equal to negative x minus 4. From there, you want to get y by himself, so you divide by negative 2. Divide by negative 2, divide by negative 2. Cancels, and you get y. Now, remember, when we divide by a negative, we always flip that sign to get y is greater than or equal to, and then you continue dividing like normal. Negative x divided by negative 2 is a positive 1/2 x, because there's a negative 1 right there. Negative 4 divided by negative 2 is a positive 2. So this is one of our equations. I'm going to go ahead and graph that, starting at positive 2, up 1 over 2, up 1 over 2. Remember, your slope is rise over run. You can extend that line back in order to continue graphing it. It's going to be a solid line. Then the next line is already solved for in mx plus b. So I'm going to start at my y-intercept of negative 1. And I'm going to go up 1 over 2. Up 1 over 2. Continue that down here. Now, if we were just graphing regular systems of equations, we would say that these guys have no solution because they're parallel. But because they're inequalities and we're going to be shading, they might have a solution. So let's double check where we shade. We're going to shade above our black line because y's are greater than the line. So I'm going to shade in black above our black line. And then here, for our purple line, it says y's are less than the line. So we shade below the purple line. And what you notice is it's actually the same for this inequality solution. There is no solution here because there's no overlapping shading. So, no solution. One way that there might be a solution in parallel lines is if the shading is in the middle, like number 10. So when we look at number 10, it already has our two lines graphed for us. They're two vertical lines, so two x equals lines. And it says tell whether the ordered pair is a solution of the system of inequalities, and then write the system of inequalities. So the first thing we want to do is tell whether or not this is a solution. So what you want to do is graph that point, negative 2, positive 3, and you want to see if it's in the shaded area. It is, so it is a solution. And then you want to write the system of inequalities. Like I said earlier, these two are vertical lines, so I know it's going to be x equals a number. This first one here, we'll do it first. Notice it's a dotted line. This shading is going greater than that line, and so it's going to be x is greater than, no equal to, because that would make it a solid line, and then this is the value of negative 3. So that's the first equation. The second equation is a solid line, and it's being shaded to the left, so that's the less than or equal to sign. The x value here is positive 2, so that's your second inequality. Number 12 says match the system of inequalities with its graph and show your work. So you can't just guess here. I don't want you to just write A, B, and C down here on the answers, but we're going to find number 12. The first thing I notice here is x is less than a negative 2. I know that's going to be a vertical line because of that V at the top of the x tells me it's vertical, and that vertical line is at negative 2. And notice all of your scales here are counting by 2s. So what I notice is both B and C have a vertical line. C is right there, B is right here. B is at a positive 2 and C is at a negative 2. So 12 automatically is actually going to be C because of the vertical line at negative 2. If we wanted to double check, we could also go here and solve for y equals by subtracting x on both sides. So you'd get y is less than or equal to negative x plus 4. And double check to make sure that my y-intercept is positive 4 and my slope is a negative 1. And it is. It goes down 1 over 1. So number 12 is C. Page 3. Says solve each system by substitution. We know there's a lot of ways to solve, but you do have to follow the directions for each section. So this section is substitution, which means I want to solve for one variable first and then plug it into the opposite equation. So number 14 already has y solved for. So I take what y equals and I plug it in to the opposite equation where there's a y. So 7x minus 2x equals 35. And then I solve for x. 7x minus 2x is 5x equals 35. Divide by 5, divide by 5. So x equals 7. And that's part of my solution to my system. We remember that all systems have a coordinate answer. So it's going to be x comma y. In this case, the x is 7. In order to find y, we plug in to either one of our equations. I'm going to actually plug into this one because it's the easiest. Y equals 2 times 7. So y equals 14. So my solution is 7 comma 14. If I wanted to double check, what I would do is plug that back into one of my equations. So the y is 14 and the 7 is 2. And you can check to make sure that you get a true statement here. 2 times 7 is 14. 14 equals 14. That's right. Excuse me. Excuse me. So 14 equals 14 is a true statement. That means I've done this right. The next one. Excuse me. Number 16. Number 16 is one extra step because one of my equations isn't solved for yet. So the first thing you want to do is solve for one of your equations for x equals a number or y equals a number. It doesn't matter which one, but you want to get one of the variables isolated. So I'm going to start with this one, and I'm just going to solve for the x by subtracting y on both sides. So I get x equals a negative y plus 3. What I'm going to do is I'm going to take that negative y plus 3 or 3 minus y, either way, and I'm going to plug it into where there's an x. So you plug in 3 times negative y plus 3 plus 2y equals 9. And you just write the rest of your equation just like normal. And just instead of that x, we substitute in the negative y plus 3. Distribute that 3, so you get negative 3y plus 9 equals, or plus 2y, excuse me, equals 9. You want to combine like terms. Negative 3y plus 2y is a negative 1y plus 9 equals 9. Subtract 9 on both sides. You get negative y equals 0. So you would divide by negative 1, which makes y still equal 0. So I know my answer is going to be in that coordinate point notation. The y is 0. And then you want to plug that into one of your equations to solve for the x. So I'm just going to go back to this original x plus y equals 3. X plus y equals 3, sorry. So, and I'm going to plug in a 0 for that y. So x plus 0 equals 3. And you would subtract 0 on both sides to get x equals 3. And you can always double check your solution just by taking these two coordinates and plugging them back in here. You could do 3 times 3 plus 2 times 0 equals 9. Double check to see if that's true. 3 times 3 is 9, plus 0 is 9, and that is a true statement. 9 plus 9 equals 9. So, sorry that work was kind of messy. Blame it on the allergies. Alright, number 18. This next section is asking us to solve by elimination, which is kind of my favorite. I like it more just because it seems like it's a little bit more simple. You want to look for something that's going to eliminate when you're solving by elimination. A lot of times it'll be two things with opposite signs, or maybe they're opposite numbers. And sometimes you'll have to multiply in order to eliminate. But for this first one, number 18, the positive y and the negative y, they automatically cancel when you combine. So these guys are going to eliminate when you combine the rest of it. And then you just add everything else that's left. So 7x plus 5x is 12x equals 22 plus 14 is 36. Divide by 12, divide by 12, x equals 3. And then just like we were doing at the top, you always want to go back and plug that in. You know that your x coordinate is going to be 3, your y coordinate is something else, and you just plug it into one of your equations. So I'll plug into maybe this one. 5 times 3 minus y equals 14. So 15 minus y equals 14. Subtract 15 minus 15. So you get negative y equals a negative 1. Divide by negative 1, divide by negative 1, so y equals 1. So your solution is 3, 1. And then you can always go back and double check your work and make sure you got it right. So for instance, 5 times 3 minus 1 equals 14. 15 minus 1 equals 14, and that is a true statement. So you've done this correctly. Number 20 is a little more complicated because you're going to have to multiply by something in order to cancel. You could multiply both equations by a number in order to cancel out your x's, or you could just multiply this first equation by 3 in order to cancel your y's. Then the first equation would give you 9y. When you multiply an equation by a number, make sure you distribute all the way across. So you get 15x plus 9y equals, and then 17 times 3. 17 times 3 is 51. And you want to write that other equation right underneath it. And remember, you're combining or adding everything together. And when you do that, these guys cancel because they're exactly opposite. When you add these, 15x plus 2x is 17x. Then you can add these. 51 plus 17 is 68. Then you would solve for x. So you divide by 17, and you get x equals, let's see, 68 divided by 17 is 4. I like it when they come out to whole numbers. So you got the x is 4. And then in order to solve for y, just like we've been doing, we go back and plug in. So I'm going to plug into the bottom equation because I think it's the most simple. 2 times 4 minus 9y equals 17. So you get 8 minus 9y equals 17. Subtract 8. You get 9 equals a negative 9y. You divide by negative 9 to get y equals a negative 1. You could go back and double check your work to make sure that that's correct. That's it for pages 2 and 3 even. For Unit 2D, please come in and see one of your teachers in order to get some tutoring.